Well, it's time to focus our attention in a very specific area of the Cisco UCS. I'm serious, a very specific area. You ready? Let's focus on how the B series servers are going to connect to our UCS infrastructure. Think about it. These B series servers are inside the chassis. You've slid them in the chassis. They're going to connect to that chassis, and then they're going to connect to the rest of your data center infrastructure. And if you're dealing with a public data center, the rest of the world. It's an amazing point of hardware in our UCS system. Let's talk about this B series physical connectivity in great depth. Now, I need to start out here reminding you about oversubscription in your UCS system, right? Here I have an input-output module. This is the 2208. Remember, the IOM is inside your chassis. The IOM supports 8 connections out to servers. There's 4 connections for each slot. So you've got those 8 connections, 4 connections for each slot. That's 32 potential connections to your Blade servers. Now, with the connectivity that we have between the input-output module and your Fabric Interconnect, there can be up to 8 links. If we were to only use one link, one 10 gigabit per second link from the input-output module to the Fabric Interconnect, what would our oversubscription ratio be? Well, it would be 32 to 1, wouldn't it? Because we have these 32 connections out to the Blade servers, 4 per port, and then we've got the 1 connection up to the Fabric Interconnect. Obviously, we can support different numbers of links, as we indicated. The 2208 and the 6248, as I've drawn here, could support 8 links, and this, of course, would reduce the oversubscription that we have in our UCS. Now, I know what you're thinking. Are there any topologies where you could get a 1-to-1 ratio? And there is. Yeah, if you were using the 2208 and you were using the 6248 UP for the Fabric Interconnect, and you were using a very specific network card, like the UCS M81KR virtual interface card, this particular card over on the IOM, so let me draw a little miniature version down here, it would support 1 connection per your 8 connections to Blade servers, right? So it's 1 connection for each of those. You get the idea, all the way to 8. And guess what? We can connect 8 uplinks, 5, 6, 7, 8, there we go, to the Fabric Interconnect. And this indeed would give us our 1-to-1 oversubscription ratio. In other words, we're not oversubscribed, right? So, very specific configurations can be implemented to reduce or eliminate oversubscription. Now, remember too that this connectivity does what's called static pinning. If I drop another link in here between our input-output module and the Fabric Interconnect, and another link's a really good idea, it will engage in static pinning. In this 2-link topology, the interfaces for our Blade slots 1, 3, 5, and 7 will be statically pinned to the first link, and the interfaces for slots 2, 4, 6, and 8 will be statically pinned to the second link. Now, of course, I've got some great news for you here. The hardware that I've shown you in this illustration, the 2208 for the input-output module, the 6248 for the Fabric Interconnect, for example, it supports creating, a port channel. Yeah, awesome. So we can have a port channel. In fact, we could do this with all 8 of our links. And now these internal server connections will be linked or pinned to the port channel. This is great, obviously, because a wonderful advantage here is if there is a failure of one of these uplinks, the servers will not lose this data path because the port channel stays up and operational as long as there is one active link inside of it. But I'm sure you're curious, what happens if we're not port channeling and there's some type of failure? So you can see here I have our input-output module, I have our fabric interconnect, and I have 4 uplinks that is utilized between the input-output module and the fabric interconnect. In this particular case, let's just say we're using hardware that only supports 4 uplinks. An example of that hardware, of course, would be the 2104 input-output module, which only supports those 4 uplinks. Okay, so we have disaster strike, a little mini disaster, I should say. One of our uplinks does indeed fail. Well, if these blade servers are configured for hardware failover, that would be nice. What they'll do is they'll immediately start using the second IOM in the chassis, and they'll start utilizing the second fabric interconnect. Yeah, remember we have Fabric Interconnect A and Fabric Interconnect B in a redundant topology. If they are not configured for that hardware failover and they can't failover to the other input-output module and other Fabric Interconnect, they are indeed going to lose connectivity. There is not an automatic repinning that is done in this particular topology. What can you do to get them back online? Well, you can do what's called re-acknowledging the chassis. We re-acknowledge the chassis. Now, a 3-link uplink configuration is not supported. So sure enough, what will happen after re-acknowledgement is there will be a 2-link topology that is recognized, and our devices will be repinned to the 2-link topology that is indeed supported. So, very interesting, probably a bit counterintuitive how this works, and I really want you to pay attention here because obviously this is hugely important in both production and certification environments. Now, I want to make sure that you're clear on the communications intelligence in our unified computing system because I find a lot of students just really struggle with this, and it's not surprising. So what I've drawn here is our UCS system with a B-series blade in the chassis. Notice we've got our redundant input-output modules. Our redundant input-output modules have intelligence inside them for management called the Chassis Management Controller. Inside our B-series device, we have intelligence called the Cisco Integrated Management Controller. This is a chip on the motherboard of each of our blade servers. It provides for thermal, power, general health monitoring on our blade. And this information is going to be communicated to our chassis management controllers and then relayed up to, of course, the UCS Manager software. Cisco's Integrated Management Controller also is the component that enables keyboard, video, and mouse support. We know keyboard, video, and mouse support allows our UCS administrators to connect remotely to the console of any of those servers in the UCS system. It also provides for serial over LAN capabilities, which allows our external UDP connections to the serial console port, and it also provides for that IPMI management that we spoke of in an earlier nugget on monitoring and logging in this course, and that, of course, provides access to the integrated management controller even if the server is powered off in a standby mode. So these internal components are absolutely critical for the health and the monitoring capabilities of B-series connectivity and beyond. Now keep in mind that there are many different blade server network interface card options to make that connectivity to the input output module. And some of these, like the virtual interface card 1280, can form port channels between the B series device and the input output module. This is obviously a beautiful configuration and really lends itself to redundancy and a failure not causing a big problem. Let's draw in the 6200 series UP and then our 2200 series IOM and then our VIC 1280. Think about it. We have 4 links here between the Blade server with the VIC 1280 and the input output module that can be port channeled. And then we have up to 8 links here, and those can be port channeled. So earlier when I was showing you how if we're not port channeling, there's a link failure right in here, it can be a real nightmare. Understand that we can really do away with that through our fabric port channels and really add a high availability to the design that is quite impressive. Now, in today's nugget, I mentioned the acknowledgement of the chassis, right? That's a key ingredient where the hardware and the configuration of your chassis and the fabric interconnects is analyzed and inventoried by the UCS manager. It's a critical process. I want to remind you where that is. So here we're on the equipment tab. I'm going to go in and I'm going to select our chassis that we have in our topology. Notice we have the ability, let me highlight it here, we have the ability to acknowledge the chassis manually right here on the General tab when we have that chassis selected. Yeah, that's literally saying, look, I want a re-acknowledgement right now. And that's how easily you could trigger that. Let me do it. We just click it. It says, are you sure you want to acknowledge chassis 1? This operation will rebuild the network connectivity between the chassis and the fabrics it is connected to. I say yes, and that process carries out. In an actual production environment, you could go over to the finite state machine tab, of course, as we've described for you, and you can follow the process of that complex event that you just did in the UCS system. Now, there's another very important concept here I need to teach you about, and that is the chassis discovery policy. Let me explain this. First of all, where do we find the chassis discovery policy? Well, we're going to go to Equipment and then choose the Equipment node, and then we're going to go to the Policies option here, and notice under Global Policies, we're going to have our chassis and FEX discovery policy. What's going on here? Well, we are saying how many links should we use to carry out the discovery process. Notice that if we were to set it to 1 link, for example, okay, what would happen would be if we had a 4-link setup, 1 link would be utilized for the discovery, and initially the chassis would be discovered as a 1-link chassis to its fabric interconnect. Then when we re-acknowledge, the other remaining 3 links would be recognized. So if you want to optimize this and you know for absolute certain that you're going to be in an 8-link environment, you could go ahead and you could set the chassis discovery policy to 8-link. As a matter of fact, if you know you wanted to do the great 8-link port channel configuration, you would come in here and you would say 8-link port channel. And you would say, look, right on the initial discovery, I want my 8 links recognized, and I want them recognized as their port channel configuration. Understand that there are implications here, right? For instance, if you set it to this 8 links and you have 1 link to the input-output module, in reality, you're not going to discover the particular chassis. So keep this in mind. If you get aggressive with this discovery policy, you need to be providing that level of connectivity in your actual UCS implementation. So let's wrap up this nugget with a little exam time. You have 4 links between your I/O module and your Fabric interconnect. You want these discovered and bonded into a port channel. What chassis discovery policy should you set? 1 link, none. 8 links, port channel. 2 links, none. 4 links, port channel. Sometimes things in the exam environment are so easy, you're going to feel a little off balance. You're going to feel like, wait a minute, this can't possibly be the question. There's got to be a trick here. No, there's no trick in this one. So if we have 4 links between our, well, let me get the right drawing tool here. That was weird. There we go. If we've got 4 links between our input-output module and our Fabric interconnect, then we want a 4-link discovery policy, and we want a port channel, so we'll set it to port channel. Now remember, while D is the correct answer here, remember there are going to be caveats to this. We do need to make sure we have these 4 links and they're up and operational. Okay? Because if we had just 2 links in place, for instance, we're not going to be able to discover the chassis setting the discovery policy aggressively like this to the 4 links. Well, what an important, a shorter nugget, but a very important nugget here in our DCUCI course. I hope this has been informative for you, and I'd like to thank you for viewing.